Welcome to our deep dive, fellow medical microbiologist. Today we're taking a closer look at Bacillus cereus, and we've got a lot to cover. We'll be using some great resources like MicroWiki Gemini and MicroCanvas, even tapping into some AI insights from Notebook LM. Get ready to explore this fascinating bacterium.
It's a bacterium many of us encounter more often than we think. It's gram-positive, facultative anaerobic, and it's everywhere.
It's part of a bacterial family you're all familiar with, but let's hear more about that.
Yes, Bacillus cereus is part of the Bacillus cereus group, and it has some interesting relatives. Some you might even say are infamous, like Bacillus anthracis.
The one that causes anthrax, that's one relative you want to keep your distance from. Are there any others?
Definitely Bacillus thuringiensis is another member of the group.
Ah, yes, Bacillus thuringiensis. I've heard of that one. Isn't it used in agriculture?
It is. It's commonly used as a biopesticide because it produces toxins that are harmful to insects. But back to B. cereus, it's got its own unique characteristics, one of which is its motility.
Motility, that sounds important, especially when we're talking about a bacterium that's found practically everywhere.
You're absolutely right. B. cereus is highly motile, which helps it spread easily through the soil, its natural environment. And that's how it gets into our food, making it a common cause of food poisoning.
Food poisoning. Oh, yes. That's one thing B. cereus is notorious for. What are the different types of food poisoning it can cause?
Bacillus cereus is linked to two main types of food poisoning, diarrheal and emetic syndromes, and they have very different mechanisms.
How so?
Well, the diarrheal syndrome is caused by toxins that target the gut, leading to those classic symptoms. We all know diarrhea and abdominal cramps. But the emetic syndrome, that one's caused by a toxin called cereulide, and it actually affects the brain, causing nausea and vomiting.
So that's why the symptoms are so different. It's fascinating how one bacterium can have such diverse effects. What's even more interesting is that I read cereulide is heat stable. Is that true?
It is. Cereulide can survive even boiling temperatures, which makes it particularly concerning from a food safety perspective. You can cook food thoroughly and still not eliminate the risk if it's been contaminated.
So how can we prevent outbreaks if cooking doesn't always eliminate the toxin?
It really comes down to preventing contamination in the first place. Things like proper food storage handling and preparation are crucial. It's not just about killing the bacteria, it's about stopping it from getting into our food in the first place.
This all makes me realize that B. cereus is more than just a food spoiler. It's actually a serious opportunistic pathogen. And that's especially important for us as medical microbiologists.
Exactly. It can cause various infections, especially in people who are immunocompromised. One particularly serious infection it's known to cause is B. cereus endophthalmitis.
Endophthalmitis, that sounds serious.
It is. It's a severe eye infection that can lead to vision loss if not treated promptly.
So what should we look for if we suspect B. cereus?
Well, under a microscope, B. cereus appears as gram-positive rods. They have these distinctive square ends, and they often form chains, creating what we call a bamboo appearance.
Bamboo appearance, I'll have to keep an eye out for that. What about culturing B. cereus? Are there any distinctive features there?
Absolutely. On blood agar B, cereus colonies have a very unique appearance, often described as a Medusa head.
Medusa head, that's quite a visual.
It is. They have this matte, opaque, whitish to cream color, and a characteristic hemolytic pattern.
So those visual cues could be really helpful for a preliminary identification hole.
They can be, but of course we always need to confirm with additional testing.
Of course. So to recap B, cereus is a bacterium with a dual personality. It can be a food contaminant, causing those annoying bouts of food poisoning.
But it can also be an opportunistic pathogen capable of causing some serious infections. And one more important thing to remember, it's resistant to penicillin.
Ah, yes, that's crucial information for treatment. Okay, medical microbiologists, let's see how well you've been paying attention. It's quiz time. Are you ready for some exam-style questions? Okay, first question. What are those two other bacteria that come to mind when we think about Bacillus cereus?
It's those relatives we discussed earlier, remember? Bacillus anthracis and Bacillus thuringiensis.
Ah, yes, of course. They really highlight how closely related bacteria can have such different effects.
Absolutely. B. anthracis causes anthrax, a serious and sometimes fatal disease. And then there's B. thuringiensis, which is used as a biopesticide because of its insecticidal properties.
Very different indeed. Okay, on to question number 2. What is it about the emetic toxin cereulide that makes it so tricky to deal with in terms of food safety?
That would be its heat stability. It can survive boiling temperatures, so cooking alone won't always eliminate the risk.
So even if food is cooked thoroughly, it could still be contaminated.
Exactly. That's why preventative measures are so crucial. Proper food handling, storage, all of that. It's about preventing contamination from the start.
Got it. Question number 3. Besides food poisoning, what other serious infection caused by B. cereus should medical microbiologists be aware of?
That would be the eye infection we talked about earlier, B. cereus endophthalmitis.
Right. That could be really dangerous. Can you remind us why?
Of course, B. cereus endophthalmitis can develop very quickly after trauma or eye surgery. It causes pain, redness, decreased vision, sometimes even discharge from the eye, and it can spread rapidly inside the eye, leading to vision loss if it's not treated quickly.
So early diagnosis is key.
Absolutely. We need to collect samples of ocular fluids and then do a gram stain and culture. And of course, we'd look for those characteristic features we discussed.
Like the bamboo appearance under the microscope in the Medusa head colonies?
Precisely. Those visual cues can be very helpful, but for a definitive diagnosis, we need to isolate and identify B. cereus from those ocular samples.
Makes sense. Okay, question number 4. This one is about those visual characteristics. What is the distinctive appearance of B. cereus colonies on blood agar?
Remember the Medusa head, that matte, opaque, whitish to cream color, and the hemolytic pattern?
Right. Those visual features are so helpful for initial identification.
Definitely. They give us a good starting point. All right, ready for the final question?
Bring it on.
Okay. When it comes to treating B. cereus infections, which antibiotic is it known to be resistant to?
That would be penicillin.
That's right. It's crucial to remember that penicillin resistance, when choosing an effective treatment, we'd likely need to consider alternatives like vancomycin.
So even though it might seem like a colon bug B, cereus can pose some real challenges.
It certainly can, and its resistance to penicillin is a key factor in managing those challenges.
All right, so there you have it, a crash course on Bacillus cereus. From its family ties to its role in food poisoning to its ability to cause serious infections like endophthalmitis, it's a reminder that we can't underestimate any bacterium, even the ones we think we know well.
Definitely. We always need to stay informed and be ready for those unexpected challenges.
So as we wrap up this deep dive into Bacillus cereus, what are your main takeaways for our listeners?
Well, the biggest takeaway, I think, is to remember that B. cereus is more than just a cause of food poisoning. It's an opportunistic pathogen that can lead to serious infections, especially for people with weakened immune systems.
And that penicillin resistance is a crucial consideration when it comes to treatment.
Absolutely. And this deep dive has also shown how important those visual cues can be. The bamboo appearance under the microscope, the Medusa head colonies, they give us those initial clues.
But it's always important to confirm with further testing.
Right. Microscopic examination, culture characteristics, biochemical tests, we need all of those for a definitive identification.
So for our medical microbiology listeners out there, what's the one key message you want them to take away from this episode about B. cereus?
I'd say always be on the lookout for B. cereus, especially when you see patients with gastrointestinal symptoms or eye infections, particularly if they've had recent trauma or surgery.
Excellent advice. And remember, stay up to date on the latest research and guidelines because the world of microbiology is constantly evolving. Thanks for joining us for this deep dive into the world of Bacillus cereus. It's been a pleasure exploring this fascinating bacterium with you.
My pleasure.
And to all our listeners out there, be sure to check out those resources we mentioned, MicroWiki Gemini, Microbe Canvas, and Notebook LM. They're packed with even more information about Bacillus cereus. Until next time, stay curious.